In yesterday's class, we factored expressions using common factoring. As you can see here in 5.4, based on this general expression, B and C are just numbers. So here's an expression that is most likely not going to have any common factors. What I'm going to start with, though, is an expanding question. If we had something like x plus 3 times x plus 4. And I hope you can view this as these are the factors and the trinomial we're going to get when we expand this. So when we expand this out, it's x squared plus 4x plus 3x plus 12, which equals x squared plus 7x plus 12. As you can see here in this trinomial, there are no common factors, but it is in the form given in the title, x squared plus bx plus c. You see any connection between the numbers we end up with in the brackets and the numbers in the original trinomial? What you should notice from the brackets is the two numbers in the brackets above add to positive 7, and the two numbers multiply to the last number. They multiply to 12. In the next expression, we're going to try to factor x squared plus 7x plus 10. What we learned from the previous example was we're looking for here two numbers that add to 7 and multiply to the constant at the end plus 10. Probably easier to think of the numbers that multiply to 10, which also add to 7. Two numbers that work, that multiply to 10, as well as add to 7 are plus 5 and plus 2. So the original trinomial would factor to, obviously, x in each brackets, so that x times x gives you x squared, and then the numbers you found from the little part we did above it, so x plus 5 and x plus 2. In example 3, we'll introduce some negatives into the question. So if I asked you to factor, let's say y squared minus 3y minus 10. Once again, as in any question that's involving factoring, you should always look for a common factor, which once again, in this case, there are none. So can we find two numbers that add to this number and multiply to this number? So add to negative 3.
This is Gonzalez Fidel here in the building, call 406.
And multiply to negative 10. I guess at this point you know where I'm recording this. Two numbers, once again, that multiply to negative 10. One's got to be a positive, one's got to be a negative. Because they add to negative 3, the larger of those two numbers has to be the negative. So the numbers that work are negative 5 and positive 2, which is going to give us the two brackets. Y subtract, well, y in each bracket. And then the numbers you found, minus 5 and plus 2. You could always check your final answer by expanding and see that you end up with the trinomial we started with. As I mentioned previously, you should always try to factor in any factoring question, I mean common factor. Looking here at the expression in example 4, all the terms share a common factor of 3, so we should take that out first. And that would leave us with c squared subtract 4c minus 12. The trinomial that remains in the bracket is of the form x squared plus bx plus c, although the variable we're using here is c. So let's see if we can find some numbers that add to negative 4 and multiply to negative 12. Once again, because they multiply to a negative, we need a positive and a negative, and because they add to a negative, the larger of those numbers needs to be the negative. So numbers that multiply to 12, 4 and 3 doesn't add to 4, but negative 6 and positive 2 seem to add to negative 4 and multiply to negative 12. So we rewrite the bracket now. The 3 stays part of it. Our one bracket becomes two brackets, c in each spot for your c squared, and then minus 6 and plus 2. It could be c plus 2 and c minus 6, but the key things are it's got to be the minus 6 and the plus 2. That's all for today.